Hey everyone, welcome to another episode of Science Man Says, and this week we'll be talking about a new method of processing milk called Pascalisation, which allows the milk to last for 2 to 3 months refrigerated. But before we go into that, we need to talk about pasteurisation. Now this is the old-fashioned method of preparing milk. This is how pretty much every bottle of milk that you'll find at a supermarket will be pasteurised. Now we start off with raw milk, fresh from the cow, and the thing is with raw milk is it actually has quite a lot of fat in it. It contains very large globules of fat, and those are actually a lot less dense than the milk itself, so they tend to stick to the top of the milk. Now to break down these fat globules and get them evenly spread throughout the milk, we pass it through a homogenizer. That basically consists of forcing the milk at a high pressure through a very small chamber, through a very small space. And that breaks down the fat globules into smaller sizes, and that allows the fat globules to be distributed a lot more evenly throughout the milk. Once we have our homogenized milk, we can pasteurize the milk via one of two methods. So the first method is to create the large bottles of milk that you see in the refrigerator section at the supermarket. And that consists of heating the milk up to 72 degrees Celsius for around 15 seconds in a large tank like this, where it's being mixed around during that time. And that produces milk that lasts for around 2 weeks. The other method produces long life milk, and that's where we heat the homogenized milk up to 135 degrees Celsius for around 5 seconds in a very similar pasteurization tank. And the resulting milk lasts for around 3 months, and you can find this long life milk in the supermarket on the shelves, not in the refrigerated section. Now, the reason why we do pasteurization in the first place is actually to kill bacteria present in the milk. And it works quite well. Like I said, the milk lasts for anywhere from a few weeks up to a few months, depending on how high the heat is. The thing is, milk actually contains a high amount of proteins and vitamins, such as vitamin B12, vitamin B2, vitamin E, and vitamin D, as well as enzymes that help us actually break down and digest the milk once we've consumed it. But what the high heat does is it actually stresses out the bonds within these vitamins, and it causes the bonds to actually break down, so these vitamins are disintegrated. And a similar thing happens with the enzymes over here. Now, how an enzyme works is it actually has a very specific structure, and it fits a very specific substrate and reacts with a specific substrate. Now, looking at this diagram of an enzyme, we see it actually has a lot of weird curls and weird lines in it. And those curls and lines are actually because of really small bonds that are occurring in the enzyme. Now, what the heat does is that, again, it breaks down those bonds in the enzyme, and we actually lose those curls. So the enzyme loses its shape, and then because it's lost its shape, it actually can't fit the substrate into it anymore, so it loses its function. Now, the other method of processing milk is using Pascalisation. Now, this is under very, very high pressure, as opposed to a high temperature. Now, the milk starts off being homogenized, but instead of being heated up, it's put inside bottles, which go inside a basket, which is put inside a chamber here. And that chamber is filled up with water, and then we have a mechanical force like a piston that compresses the water, increases the fluid pressure, and that increase in fluid pressure is actually what allows us to break down the bacteria. Now, the temperature is below 45 degrees Celsius, or 113 degrees Fahrenheit. And the reason it's that low is because it actually leaves all these vitamins and all these enzymes intact. We pressurize the milk to 500 to 700 megapascals, or around 72,520 to 108,778 psi, or for normal people, 7,400 times our room pressure. And the significance of that very high pressure is it actually doesn't destroy any bonds present in these proteins, but what it does is it actually bursts the bacteria present in the milk. And it actually disrupts the bacteria's ability to transcribe DNA, so it can't produce new bacteria. So via Pascalisation, we actually produce less bacteria. And of course, bacteria increasing and multiplying over time actually means that the milk will last longer because we have less bacteria to start off with. And that's how we have milk that lasts for 2 to 3 months, compared to pasteurization, which doesn't actually kill as many bacteria, which is why it goes off much quicker. Pascalisation can actually be applied to a wide range of different foods and drinks, like avocado, eggs, fish, dips, poultry, cold cuts, microwave foods, salads, and fruit juices. Now, as long as those foods don't actually have air pockets inside them, because putting them in a pressurized container will actually cause the food to implode, which, is quite messy. So the Pascalisation process actually allows these different kinds of foods to be processed and given a much longer shelf life. It can be transported into areas that don't have that much of a variety of foods to eat. Alright, that's all for this week, guys. It was a bit of a short video. I hope you still enjoyed it nonetheless. If you enjoyed, leave a like and subscribe if you haven't already, and also comment if you have any questions. I'm more than happy to ask them. Thanks for watching.